All right, so time now for a little bit of coordinate geometry. We're in the coordinate plane or the Cartesian plane. If we're trying to measure distances or find midpoints, so that's the type of problem we're looking at here. So a couple of points here. This is the quote-unquote easy one. So from A at this point, -5, 3. So 1, 2, 3, 4, 5 in the x direction, up 3. So we would have that point right there, A at -5, 3, and then we have B at -1, 3. So -1 up 3. So we've got that, and we're going to do a segment AB. So if you draw that on there, so that's segment AB. So what is the midpoint between those two? I mean, you can kind of just spot it on this in this case. So if it's that segment is 4 units long, 1, 2, 3, 4. Halfway across would be 2 there, 2 from the left, 2 from the right. That point right there. So that midpoint would be at -3 and 3. So -3, 3. That would be the location of the midpoint. The midpoint is a point, and that's where I give the location of a point in coordinate geometry. All right, so then what is the distance from A to B? Maybe even easier than that. So the distance from A to B, we're just going to count straight across the line. 1, 2, 3, 4. That is 4 units away. All right, so not too bad there. Where it starts to get not so easy is if they aren't just on a straight line, either horizontally or vertically. So if we get some points here, C is at -6, -5. So -6 in the x direction. So 1, 2, 3, 4, 5, 6, down 5 in the y direction. So that is point C. And then D is at 7, 3. So 7, 1, 2, 3, 4, 5, 6, 7, up 3. So that is point D. Okay, so my segment here is, let me get a little straight edge. My segment is from there to there. All right, so that's the segment that we're talking about. Now it's not so easy. The midpoint, you can kind of eyeball it. It's somewhere in the middle there, but yeah, it's certainly not as easy, especially since the distance is not as easy. We can't just say that it's 7 over, sorry, not 7 over. It went from -6 to 7. So that would be, if you counted all of them out, 13. So it's 13 over, it's 8 up, yeah, we still don't have immediately distance from that. So figuring out that midpoint can be a little bit trickier. So here's where we actually have a couple of formulas that come in. The midpoint formula comes from the idea that we're going to be halfway across horizontally. That midpoint's going to be, if I think about that distance that we're going, we're going to be halfway across there horizontally, and we're also going to be halfway across, halfway up vertically. If I can figure out half of the distance here, that's my midpoint would be there. But I also figure out I'm going up. If I go half that distance, we're going up. So it's kind of half of both those distances. So the midpoint formula looks like this. It's actually a coordinate. So I'm going to start out with something like that. We're going to get an x-coordinate and a y-coordinate. The x-coordinate is going to come from, we're going to do x2 minus x1. You could do this a couple ways, but I'm calling this like the x-coordinate. So in this case, I'll show you this calculation. But from this point back to that point, I'm going to kind of subtract the bigger value minus the smaller value, and then. Ooh, I'm doing this wrong. Sorry. This is distance formulas plus. So I was thinking about distance. That's what will get applied in distance. So let me actually even change this around. I apologize. It doesn't matter the order. x1 plus x2. I was getting to distance. You could do x2 plus x1 if you want. But you add the two for trying to find the midpoint in between, and then we average them. So if you add those 2 points up and average them, that'll give you that horizontal midpoint. So let's start with that here for the x-coordinate for the midpoint of CD. If I add the x's, so -6 plus 7. So if I add those two up and then divide that by 2. I'm finding the average, the halfway point of those two. So -6 plus 7 is 1. So -6 plus 7, and then over 2. So we get the halfway point. And so if I figure out what that is, so we'll get this midpoint is going to be at the x coordinate. So that's 1 over 2. It's going to be at the point 1/2. So you can kind of spot that my x 1/2 is actually the average of those two. The other way you could have thought about that is, like I did already kind of mention, that distance horizontally is 13. Well, and so that's kind of actually where I was thinking about distance. But you could also think about this another way and say, okay, well, I need to go half of 13. Half of 13 would be 6.5. So if I add, if I go 6.5 from -6, we'll end up at 0.5 or 1/2. So that's the x coordinate. The y coordinate, we do the same thing where we add those two. So y1 plus y2, or you could do y2 plus y1. Order doesn't matter with addition. And then average those two. So we kind of get the average of those two y values. So my y values are from -5 and 3. So -5 plus 3. So that's at -2. Divide that by 2. -2 divided by 2 is -1. All right, and so at, can't quite squeeze that on there. So our midpoint would be at 1/2, -1. So if I go 1/2 in the x direction and 1 down, should be on that line if I've drawn this appropriately. So that is 1/2, -1. And that's that midpoint. Again, you could do this another way. You could say, well, we're going from -5 up to 3. We're going up 8. So really, I just need to go up 4. And so from -5, if you go up 4, you'll be at -1. Another way of thinking about it, using kind of distances. All right. So then the full distance, that diagonal distance, we want to actually tap into something that hopefully you already know, and that is Pythagorean theorem. Pythagorean theorem. All right, because we've got this diagonal distance in this like kind of rectangular plane. So what we can actually think about this as is we can think about this length there as a hypotenuse of a right triangle, and I could have drawn this over here as well. So I have this horizontal distance, which I've kind of already mentioned before, that's 13, and then I've got this vertical distance, we're going 8, but that diagonal length, we actually know, if I know that this is 13 and this length is 8, we can do Pythagorean theorem, which is you take the two legs of the right triangle, so a squared plus b squared equals the hypotenuse c squared. All right, and then if I want to solve for c, what I would do is I would do a squared plus b squared, and so you could also just write this as c is equal to the square root of a squared plus b squared. And that actually gives us that hypotenuse length. So that's effectively what that distance formula comes from. Our distance formula is going to do the square root of the two distances. So this is where I was going to do this, x2 minus x1. Right, that distance from -6 up to 7 would be 7 minus -6, and so we get that distance, and then squared plus the vertical distance, so this would be y2 minus y1. So if I subtract those, 3 minus -5 gives us that 8, that vertical distance squared. So if you add those two, so that's effectively going to be your 13 squared plus 8 squared. So 13 squared plus 8 squared is going to be those two distances. And sorry, I guess I should show out where those numbers come from. So 13 comes from 7 minus -6 squared plus, and then 3 minus -5. That's where that 8 came from. And then we're going to take the square root of all that. So we're going to take the square root of that. So 13 squared plus 8 squared. All right, so, sorry, this is, looks like 3. 13 squared. 13 squared is 169 plus 8 squared is 64. We're going to be ultimately taking the square root of that. So 169 plus 64 is 233. All right, and we take the square root of that, and we get this number. So 15 point, we'll go to a couple decimal places, 26. All right, and so that would be the measure of the distance of CD, and so I'll write that as CD. The distance from C to D is 15.26, right? It's 13 over and 8 up, but if you take that diagonal, that hypotenuse, you know, cut that distance off, so you get 15.26 for that distance. All right, so an example of another problem like this, just some extra practice. If you want, you could pause and see if you can do it yourself, because this will be much the same as what we just did. So ME has the endpoints M at -6, 4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So -6, 4 is the point M. E is at 5, -2. 1, 2, 3, 4, 5, down 2. And that is E. All right, and so I've got that segment there. Get that drawn on decently well. Oops. All right, we want to find the midpoint of those. So we can use that midpoint formula. Effectively, I'm averaging the x's. So if I take the x coordinate, -6 and 5, divide that by 2, that'll give me the x coordinate. And then the y coordinate, I can average the y's. So 4 and -2 divided by 2. All right, so -6 plus 5 is -1 over 2, so that's -1/2. And then 4 plus -2 is +2. Oh, divided by 2 is just 1. So at -1/2, 1 should be that midpoint. -1/2, or -0.5, 1. All right, so that's our midpoint. Our distance of M to E, so that's going to be that Pythagorean theorem applied. I don't actually want you to memorize these formulas. I want you to be able to just think about the idea of, okay, half those distances, so we can kind of average those x's, average those y's to get the middle point. Distances, it's basically Pythagorean theorem applied. So, you know, I'm kind of applying like this triangle to it. And it could be a triangle on the other side here, but we're going to figure out that vertical distance, that horizontal distance, and then do, you know, a squared plus b squared equals c squared. So you can kind of work it out instead of having to just straight memorize a formula. So let's get those distances. So it is the horizontal distance. So I'm going to go x2. So it's, you know, 5 minus -6. So that's how far we've traveled over. So 5 minus -6 is 11. That distance squared, that's ultimately going to be 11. So we have that plus 8. That's like our a squared. And then our vertical distance is, you know, y2 minus y1. So this actually, if I go y2, so this would be -2 minus 4, which is actually a little interesting. So you could have done this either way. So -2 minus -4 is going to be -6. It kind of is like I'm going down 6 and over 11. In measurements, that doesn't really make sense in terms of the triangle's Pythagorean theorem, but it works out fine because we're squaring it. So whether it's a +6, if you go, you know, bigger minus smaller, that's what that order of subtraction really doesn't matter, is because those squares on the outside. -6 squared, +6 squared, same thing. So I'll leave it this way. I'll match that formula, but you could have also just measured that distance as 6, since those distances we measure are usually on physical images are positive. All right, so what do we say? We said this was 11 squared plus -6. Get those parentheses on there if you're going to type that into your calculator. So we have the square root of 121 plus 36. Which is the same thing as the square root of 157, which is 12.4. 12.5. We'll round that to a 3 for a couple decimal places, so 12.53. And units, I guess, if we wanted to give them for measure for both of those distances there.